Let's talk about number 6. What kind of a function? Actually, let's talk real quick and make sure we have this written down. What type of a function is this? Square root or radical, right? What type of a function is number 5? Cube root. Okay. What type of a function is number 6? Let me ask you this question. What does this look like?
Fraction.
It's a fraction, right? What's another word for fraction? Ratio, right? Guess what this kind of function is called? Rational. Okay, good job. Rational function. Okay? So, it's 1 over a random number, right? Any number. That's what we're trying to choose from. So, wait a second. If I put like a 2 in there, what am I going to get out? Oh, no. Stay fractions. Guys, fractions are our friends. Fractions are our friends. They're not the friends that you hang out with every single day, go to the movies with, go to dinner. They're those friends that you kind of hang around with because you know they're good for you. No, I don't want anybody to say any names. Don't say names. That's not nice. If I put a 2 in for x, what is this going to become? 1/2. So I'm going to get fractions. You know that, right? You got to be okay with that for a little while. Okay? Why did I choose 2 first? Because. Yeah. Because I like that number. It's a nice number. And I knew that if I put in a 2, it's a 1/2, and I can graph 1/2 pretty okay. Right? What else do I feel confident in choosing? 4, 1. Those are the 2 numbers I just heard you guys say.
3.
If I put in a 4, that gives me 1 over 4. If I put in a 1, 1 over 1? Oh, 1. Okay. So far I have 2, 1/2, and 4, 1/4. Probably better not choose any number bigger than that because it's going to be hard to graph, right? And I don't really need to choose 3 because I can kind of see probably where 3 is, right? 1, 1. Ugh. Do I have a really good picture of what the graph looks like? No. No, I don't. What else could I choose? -1, okay. -1 would be a good one because that would give me -1. -1, -1. Oh. Well, that's weird. Guys, sometimes when we do stuff in this class, you're going to do something and be like, that's weird. And what I want you to think is, so am I. And just keep going. Okay? So what else do you think I might choose as the next value? -4 and -2. Those are the 2 I heard. That's probably good based on what we have up here. Right? So -1/4 and -1/2. Right? So -4, -4, and -2, -1/2. Okay, that makes it even more confusing. What other number do we like to choose a lot because it's usually really easy?
0.
Yeah, 0. What is 1 divided by 0? You can't divide by 0, can you? Guys, there's only one person I know that can divide by 0, and Chuck Norris is not in this class. He's not. Okay? If we had our calculators, I know I haven't given them to you yet, and that's okay because I want us to think together for a little while. Okay? But if you had a calculator and you put this equation in and looked at the table, this would either say, depending on what calculator you use, it would either say undefined or error. Error has less letters, so that's what I'm going to write. Okay? Something's wrong at 0. Nothing can happen at 0.
So it's 2.
We're getting there. Okay? So watch this. I can kind of see what's happening here, and I can kind of see what's happening here. What can I not see? Like around 0, right? I can't put anything on the graph for 0 yet because I know there's an error there. So watch this. I'm going to blow your minds. 1/2. Dun dun dun. I know. You're going to be fine. Okay? If I choose 1/2 as my x value, watch what happens. 1 over 1/2. Am I allowed to have a fraction in a fraction? No. Let me remind you, there was a lot of guesses earlier today. Let me remind you how we get a fraction out of a fraction. Okay? Right now, especially this is in the denominator, we don't like that. The only thing we can do to a number without changing its value is multiply it by 1. If I multiply a number by 1, have I changed its value? No. But I get to choose the value of 1 that I choose. Think about this. What if I took the reciprocal of the denominator? That's 2/1, right? And what if I multiply the denominator by that as well? Didn't I just choose a value of 1? Isn't that 2/2? And isn't 2/2 equal to 1? So now watch what happens in the denominator. What's 1 times 2? Okay, that took way too long. Okay, what's 2 times 1?
1.
So in the denominator right now I have 2/2. What is 2/2?
2.
Oh my goodness.
1.
Okay, let me start again. What is 2/2? 1. Excellent. So now my denominator is 1. What's left in the numerator to do? 1 times 2. What is 1 times 2?
2.
2. So now I have 1/2 and 2. What if I chose a 4th? What do you think would happen for my y value? It would be 4. That's exactly right. So a 4th and a 4. Now I have a really good idea of what this looks like, right? At least I think I do. Do I have a good idea of this side yet? What could help me? What should I choose? -1/2 and -1/4. So if I put in -1/2, what am I going to get? -2. Good. And what if I put in -1/4? -4. So -1/2 would give me -2, and -1/4 would be -4. Now, here's what you need to understand about graphing this. You cannot graph it correctly. I cannot graph it correctly because we are humans. Okay? Because what has to happen, you'll notice that as I got closer and closer to 0, what's happening to this dot right here?
It's getting closer.
Will it ever cross this line? No. But I have trouble drawing that because I'm human. Sorry. Same thing here, right? Now it looks like it goes back up. Does it go back up? No. That's just my humanness showing. Sorry. Sorry for being human.
It's okay.
Thanks. Thank you. I appreciate your forgiveness. So what happens at 0? Nothing, right? There's a name for that nothing. First of all, I'm going to draw the nothing. Why am I going to draw the nothing? So I remember that the nothing is there. But it's nothing, so I'm not going to draw a solid line. I'm going to draw a dotted line so I remember that it's nothing. And that nothing has a name. Okay? So we need to go over some ground rules about this word. First of all, we don't abbreviate it. Because even if we did, it would be ASY and not what you want it to be. Okay? Second of all, the word is asymptote. We don't unnecessarily stress the first syllable of the word. No, we don't. Okay? Last but not least, we don't need to walk up and down the hall telling each other, I'm going to kick you in the asymptote. Okay? That would be inappropriate. Especially if it was said in front of a non-math teacher, because then you would get sent to the office. And the principal would say to you, why are you cursing in the hallway? And you would say, I wasn't cursing, I was using a word Mrs. Kingston taught me. And then I get called to the office. Not that this has ever happened, mind you. And the principal says to me, why are you teaching the children curse words? I'm like, it's not a curse word, it's a math word. And I'm feeling particularly ornery at this point in the day because I've been called to the office because a kid was telling another kid they were going to kick him in the asymptote. And they said, well, what is it? And I said, it's nothing. No, I mean, really, what is it? I'm like, it's really nothing. So you're teaching them vocabulary words that mean nothing, but they sound like curse words. I'm like, pretty much.
That's good.
Okay? So, let's use the word appropriately and responsibly. How about that? Okay? So, there are two asymptotes here. Why did I say there's two asymptotes here?
Because X and Y.
I only drew one. Is there another one? Or was I just making that up? Isn't there one here also? Yeah. Thanks. So, remember, I know it's been 2 years since we've done this, for some of you 3, okay? But when we name horizontal or vertical lines, when we name them, we say what axis they cross and where, okay? So if I'm talking about this horizontal line right here, what axis is it crossing? It's crossing the y-axis where? At 0. Okay? Where's this vertical line? What axis is it crossing? It's crossing the x-axis where? At 0. So I actually have asymptotes. I have 2 of them. At y equals 0 and x equals 0. So what can live where the asymptotes are? Nothing. Okay? That's why when some of you drew this, when you drew it the first time, you went like this and then connected it and then came back down, right? You can't connect it because you can't cross that. Okay? Now, here's the deal. Later on in the semester, we're going to really talk about and discuss asymptotes, and you're going to understand them a lot better. Okay? So you're just going to have to trust me for a while that that's what's happening there. Okay? Let's talk about the domain. Yesterday when we talked about domain, we said, how far to the left does it go? How far to the left does this go? All the way, right? How far to the right does it go?
Sure thing.
All the way, right? So shouldn't our domain be all real numbers?
No.
But it seems like it should, right?
But it doesn't cross the...
But it doesn't cross 0, right? It can't cross 0. 0 cannot be part of our domain. So we can still use this symbol, kinda, if we also say x is not equal to 0. Does that make sense? Okay. We can also say let's see, x is going to be greater than 0 and less than 0. We can write it that way. Why is it not less than or equal to?
Because it's not 0.
Because it's not 0. It's exactly right. Now you remember that other way we talked about writing domain and range? With the parentheses and the brackets and stuff? Watch this. I'm going to blow your mind. Alright, so to the left we go all the way to infinity. So we start negative infinity, and as we're coming in, we get to 0, but we stop at 0, but 0 is not included. But I get all the way up to the edge of 0, so like negative 0.000000006. That's part of my domain, right? I can't write that way. So what I have to say is all the way to 0, but 0 is not included. Remember what I drew yesterday when it was included? A bracket, right? So this means I get all the way to 0 and 0 is not included. And then it starts again on the other side of 0, not including 0, and goes all the way to infinity. So this crazy kid earlier says, why'd you put a U? Well, it really is a U. It means union. That's what it stands for, union. You're unioning, you're joining 2 sets of numbers. But when we're talking about it in math, what connecting word do you think it means?
You, right?
Close. Easier than that. And. This and this. Okay? Does that make sense?
We're all taking it apart.
I know, it's okay. It's okay. Alright, what about the range? How far down does it go? All the way? How far up? So all real numbers? Oh, excellent. All real numbers. Y is not equal to 0. So 0 is greater than y is greater than 0. And what does it look like in this form? Pretty much the same, right? Negative infinity. Only thing that's different is my infinities are going to be different because I can't draw them the same every time. Right? How do you feel about that?
A little too much.
All right. Okay, you're going to have to produce this from memory tomorrow. Just kidding, just kidding, just kidding. All right, look at number 7 and number 8. We're going to kind of look at these at the same time. Look at the equation for 7 and the equation for 8. What do you notice? They're the same, right? The equation for 7 and the equation for 8 are the same. What do I have covered up? The restrictions, right? For the top one, y equals b to the x power, b has to be what? Greater than 0 and less than 1. What's another way to say that? Like in English, how could we say that? Like between, right? Between 0 and 1. Let's talk about what you said real quick. It's like a fraction. As long as I understand that you understand what we're talking about, I'll let you say it that way. Because here's what I mean. 6/5 is a fraction. Is 6/5 between 0 and 1? No. Okay? So if you'll make sure that you've made sure with me that I know that you know that that's getting confusing. We have to make sure we're on the same page. If you say it's a fraction, you know it's a fraction between 0 and 1. Is that fair? Okay, so if we choose a fraction between 0 and 1, and we're talking about number 7, we're going to get one table and one graph and one domain and range. But if we choose a b value that is greater than 1, do you think that will be the same, or do you think that will be different? Hopefully, since you realize there's two different graphs, it might be different. Okay, so let's look at number 7. What do you think is the people's favorite fraction between 0 and 1?
1/2.
Yeah, 1/2, right? Now, I don't know, you'll have to tell me, I don't know if you've honestly ever been asked that before. What is your favorite fraction between 0 and 1? Probably nobody's ever asked you that before, right? So think about that. I mean, you really have to, it's fine. So we're going to say b is 1/2. Okay? B is 1/2. So all the stuff that we do in this table and in this graph is going to be based on the equation y equals 1/2 to the x power. Okay? What kind of values do you think we should choose for x? What do you feel comfortable choosing for x? 1. What is 1/2 to the first power? 1/2, because anything to the first power is just itself, right? Do you feel comfortable squaring a fraction? Like when you square a fraction, you square the top and the bottom, the numerator and the denominator. So if I choose 2 as my x, it would be 1 over square the numerator, square the denominator. 4, absolutely. Now, I have to be upfront and honest with you guys, because I told you in the beginning, I want you to do that to me, so I want to do that to you. Okay? Some of the stuff on this one, you're just going to have to trust me. We don't get to exponents till second semester. And some of this you may or may not remember from Algebra 1. I know you were taught it in Algebra 1. This is one of the more difficult concepts in Algebra 1. Okay? So you may just have to trust me on this one, and we'll go on, and then when we get to the exponent section, then we can really talk into more depth. Is that fair? Okay. Let's do 3, because I think we're okay with cubing fractions, because we cube the top, which would be a 1, and we cube the bottom one, which would be an 8. Here's the part, let me see if you remember. If I choose 0 as my x, what's 1/2 to the 0 power? Do you guys remember that? Anything to the 0 power is 1? If you don't, that's fine. We're going to work on it. Okay? Anything to the 0 power is 1. Again, trust me here. Okay? So I'm going to go ahead and graph that so I can see like where I am so far. 2, 1, 4, 3, 1, 8. Yikes. 0, 1. Now, am I afraid there's any asymptotes right here?
No.
No, because I already have a value right there, right? So should I go to negative and see what happens over there?
Yes.
Negative. Here's where you're going to have to trust me, okay? If x is negative 1, y is 2. 1/2 to the negative 1 power is 2. If I choose negative 2, 1/2 to the negative 2 power is 4. Anybody have any guesses if I choose negative 3? 8. Okay, so graph that. Take a guess on the domain and range. Try 8 and 9 before you get here tomorrow. Okay? Hope you have a great day.